Hello, and welcome to the CCNA Routing and Switching course offered by SimplyLearn. The previous lesson focused on WANs. This lesson focuses on troubleshooting. Let us begin with the objectives of the lesson in the next slide. By the end of this lesson, you will be able to explain and configure network monitoring tools, configure automatic recovery for ERR-disabled ports, explain and configure simple network management protocol and NetFlow monitoring, explain approaches to troubleshoot various types of network problems. Let us start our discussion on network monitoring. There are many types of network monitoring. There is no one method that provides all the information needed to troubleshoot and to know network status. They complement each other. Network monitoring tools include list packet capture. This reports packet information and contents. Syslog reports system events. Simple Network Management Protocol, SNMP, is a client-server protocol that is available on nearly all network devices. It reports device status. Another tool is NetFlow. This is available on routers and some higher-end switches. It reports traffic status. In the following slides, let us discuss these tools in detail. The packet capture software must be capable of filtering packets, especially by protocol. Otherwise, the user is overwhelmed with packets that are not relevant. Packet capture is normally a last choice for troubleshooting purposes. To set up packet capture, install Wireshark or another packet capture software package on a PC. Attach the PC to a switch that is passing the traffic that you want to monitor. For Cisco devices, show and debug commands normally provide all the information a user needs. In the next slide, let us learn about syslog. A Cisco logging message consists of the percentage sign plus 80 characters. Each field in the 80 characters is separated by a hyphen. At the extreme left are sequence numbers, if they are configured, then timestamp and the percentage sign. The 80-character string lists facility, severity, mnemonic, and description. Let us look at two examples. After issuing a shutdown command on interface serial 11, two syslog messages are received. In the first, the facility is link. Note that the second has a different facility. The severity of both messages is level 5. The mnemonic for the first message is changed, and for the second message is up-down, followed by the description. Take a moment to study the output. Let us continue our discussion on syslog in the next slide. By default, logging messages are sent to the console, monitor, and syslog. Logging messages from all network devices can be directed to a central location called a syslog server. A syslog server can be a PC, server, or appliance. Centralizing the location of syslog messages has numerous benefits. One advantage is that the messages can be backed up as any other file. Troubleshooting is also easier because you can determine the extent of the problem when viewing all system messages in one place. Let us discuss syslog commands in the next slide. Use the terminal monitor command to view syslog messages from a VTY session. To verify the syslog configuration, use the show log command. Take some time to look at the configuration and verification commands. In the next slide, let us look into SNMP severity level. There are 8 severity levels. The lower the number, the more impact there is on the system. By default, in a Cisco device, the severity level is 6. Specifying a severity level as the argument for a syslog or SNMP command means that the output includes messages at that severity level and numbers at all levels below it. In the next slide, let us discuss SNMP. There are 3 components in SNMP: the server, the managed device, and the management information base, MIB. The server collects SNMP information from the managed devices. Each managed device contains an SNMP agent to collect and store device information, respond to requests from the server, and generate traps as configured. Each managed device also contains a MIB database object. This contains the categories of information that can be monitored on the device. Every Cisco device comes with an MIB preloaded. In the next slide, let us discuss various versions of SNMP. The three versions of SNMP are SNMP version 1, SNMP version 2C, and SNMP version 3. Versions 1 and 2C use community strings as passwords. There is no encryption. A community string can be read-write RW or read-only RO. Version 3 supports encryption and is therefore recommended over the other versions. An example of version 1 or 2 SNMP configuration is shown on the slide. An SNMP server at 192.168.179.1/24 needs to communicate via the SNMP protocol with managed device router 1. Assume that the server is already configured. The two commands configure SNMP on router 1. In the next slide, let us focus on NetFlow. NetFlow is a Cisco proprietary feature and tracks traffic by flow. A flow is a set of packets whose header information matches. The flow cache stores the flow information. This can include Layer 3 and Layer 4 headers information as well as interface status. Let us look into troubleshooting interface problems. There are many reasons that interfaces are not up and up. For a general overview, enter the Show IP Interface Brief command to check if the link state and protocol are up for all interfaces. To check the IP address and subnet mask, enter the Show IP Interface or Show Run commands. Let us continue our discussion on NetFlow and interface. The Show Interface command can help determine the underlying issue if there is a problem. Issue the same command on the interface across the link and compare the output. Check for speed and duplex match. Also, check if both sides are full duplex or half duplex if there are collision errors. For serial interfaces, check whether the encapsulation matches. If the above looks fine, the problem could be a Layer 1 issue. One way to approach a physical layer issue is to swap components. For example, swap cables or use a different interface on the same device with the same cable. In the next slide, let us discuss the NetFlow configuration. The NetFlow collector stores all the information sent from the NetFlow-enabled router. Note that both router interfaces are configured to pass NetFlow information to the collector. There are many versions of NetFlow. This one uses version 5. The destination configured is the address of the NetFlow collector. Port number 5000 is also specified. This is the default port for NetFlow. In the next slide, let us look at the Show Processes CPU command. If there are problems reaching devices, there could be a high CPU utilization and/or a broadcast storm caused by a spanning tree problem. One way to check this is the Show Processes CPU command. This shows the overall CPU utilization and by process ID, PID, for the past 5 seconds, 1 minute, and 5 minutes. The Show Processes Memory command is an analogous command that can be issued to troubleshoot memory problems. Take some time to review the output. In the following slide, let us discuss Ether channel. The establishment of an Ether channel requires the port channel and the underlying interfaces to be configured consistently. This is why most interface configuration should be accomplished on the entire range of interfaces used for the Ether channel. All underlying interfaces must match in speed and duplex. For a trunk, the encapsulation type, Native Virtual Local Area Network VLAN, Allowed VLANs, Dynamic Trunking Protocol must match. If Ether channel binds access ports, then the assigned VLAN must match. The trunk configuration is displayed on screen. Let us continue our discussion in the next slide. If no Ether channel negotiation is present, both sides of the channel must specify channel mode on. If Port Aggregation Protocol, PAGP, or Link Aggregation Control Protocol (LACP) is used, the same protocol must be configured on both sides of the channel. To ensure that all appropriate parameters match, follow a procedure when configuring an Ether channel. Start by specifying the range of interfaces. Apply the default interface command to return the interfaces to their default condition. Then enter configuration for the underlying interfaces. After this, any other configuration should be applied to the port channel, not the underlying interfaces. This is a simple way to consistently configure the underlying interfaces. Remember not to enter the No Shutdown command until the port channel has been configured. In the next slide, let us understand how to handle a switch interface in the ERR disable state. If you have followed the interface troubleshooting steps discussed previously, and the switch interface is still down, it could be in an ERR disable state. In that case, physically switch on the port. The LED becomes orange. There are many reasons that a port can become ERR disabled. For example, if port security is configured, the default violation mode is shutdown. The port becomes ERR disabled upon violation. Also, many spanning tree conditions can lead to an ERR disable state. The Show IP Interfaces Brief command will not show if an interface is ERR disabled. It will report down down. Use the Show Interfaces Interface or Show Interfaces Status ERR disabled commands instead. Let us continue our discussion on switch interface in the ERR disable state. By default, the port must be re-enabled manually using the shutdown command, followed by the no shutdown command. You also have the option of configuring automatic recovery. Take some time to review the commands on slide. In the next slide, let us look into troubleshooting network connectivity. There are many possible reasons for a PC to lose connectivity to the Internet. It is possible that the PC could not obtain an IP address or gateway from DHCP if it should have. DHCP could not be the problem if the PC's address is manually configured. However, the IP address, subnet mask, or default gateway could have been incorrectly entered. Any device between the PC and the Internet could be causing the problem. For example, there could be a switching problem if the access port is assigned to the wrong VLAN. There could be a routing problem in the network. An access control list, ACL, blocking communication can also be one of the causes. To verify if the PC has correct IP address or gateway, use the commands listed on the slide. In the next slide, let us discuss how to troubleshoot this. First, check if the PC can communicate with its default gateway by pinging its address. If the ping succeeds, check if the PC can communicate with the next router up the line. Continue checking devices farther away until communication is no longer successful. Now you know that the problem is between the device you are testing now and the one you previously tested. In a large network, it is important to narrow down the source of the problem in this way. Note that to discover information about neighboring devices, use the Show CDP Neighbors command. This can help to isolate the problem to a specific device, and sometimes to a specific interface. In the next slide, let us look into spanning tree troubleshooting. The network documentation should include spanning tree root bridge and configuration information. It shows the normal operation state of STP. Compare this with the present STP configuration. Since most spanning tree problems are caused by a problem with the root bridge, the first thing to do is to find the root bridge. Follow the procedure on the slide to find it. Take some time to understand this procedure. Let us discuss how to troubleshoot routing. Many show commands can help troubleshoot routing, including those involving ACLs, blocking traffic, and/or routing messages. Take some time to study the show commands. Let us move on to the quiz questions to check your understanding of the topics covered in this lesson.